let's try another examples. The second example here, right? This one is um, the rules of the transfer function is that the poles, the roots number of zeros must not exceed the number of poles. Okay, so you cannot realize that system. Even you cannot find a system when you derive it. You cannot the system that has higher zeros than poles, right? Even though in mathematics, that you can simply create any transfer function, but in the real system you can't get it, so we don't consider this. Okay, this one is okay because it's number of zeros less than number of poles. So we have total of 1 2 3 4 5 poles and 1 0. This is the closed loop systems, right? So right now in a root locus, we want to use the open loop systems to be able to predict the closed loop poles, right? Okay, now you see in this one, right? You see in this one, based on this, we can actually sketch it, right? Just not to be very accurate, but just rough. We have a rough idea how to sketch it. Okay, from here we have. Okay, let's see. We have how many poles that we have? How many poles? We have 5 poles. Okay, number of poles. Number 1. We go back to this chat list. Okay, number of a branch or number of poles. So we have 4, 5. Okay, so we have 5 branches. 5 branches. This one, right? 5. How many zeros do we have? 1. So that zeros determines the number of branch and at infinite zeros, and also the number branch at infinite zeros. Okay, so if we have 5 poles, we have 1 zeros. That means we have number of branch and at finite zero is 1. Okay, no 2 because it's 1. Number 3 here, number of branch and at infinite zeros. Of course, another 4 poles here will find its own zeros at finite, at infinity, right? So there's 4 there. So these two total must be equal to 5, right? Because this 5 pole will actually moving towards its own zeros. Okay, and then asymptotes, yes, because if there is a difference between poles and zeros, we need asymptote, because asymptote is simply, because in the previous example, that's why we don't have asymptote, because we have 2 finite poles, right, and finite zeros. So that means we know the directions, we know the location of the poles, the zeros, sorry. But in this case, there are 3. In this case, there are 4 zeros located somewhere we don't know in infinity, right? So we need the directions of the root locus so that we can actually point to that direction and in direction. So we have 4 unknown directions. One of them we know the direction is here, right? So here there's a 1 here actually finding 0 0. The rest actually finding somewhere in the infinity. Okay, we have asymptotes. Yes, we have a breakaway. Normally in this case we can say yes, breakaway point, because we need to find something in the infinity to make this symmetrical. We have a breakaway point. Yes, we have break-in point. No, we don't have a break-in point, because unless if we have break-in point only, we only have a break-in point when our poles are complex. If our poles are complex, then we have a 0 along this line, then we have to break into the real axis like this one. This one, right? We have a real poles, complex poles here, and then 0 0. So we have a break-in point here, right? So in this case, we have breakaway point only. Angle of departure, we don't have. Angle of departure only have. No, so yeah, angle of departure, if we have poles on the complex plane, complex poles. angle of arrival only have if we have zeros, a complex zero. Okay, in this case we don't have a complex zero, we don't have a complex poles, then we don't have these two angle, right? So imaginary crossings could be yes or no, depending. So later on, we need to determine this whether this is moving this direction or this direction. In this case, there's you can say is yes, right? Okay, from here we can actually simply sketch. The important um, thing to find here is that we need to find the asymptote first. Okay, the number of branch we calculate. Okay, number 4 is asymptote. Asymptote, right? This asymptote will actually guide us to sketch this. Okay, 1, 2, 3, 4. We have 5. We have 0 here, right? What's the values? -1, 0, -2, -3, -4. All right. So we know that number of poles of 5, number of pole 5. That means there's 5 branches. Number of branch ends at finite 0, 1, because there's 1 there. So that means one of them, we don't know yet, one of them will actually end up here. And then number of branch end at infinity, 4, we don't know. Okay, now how to start? We go back to the how to find the asymptotes. Okay, first we need to find the real axis intercepts. That means we have to find the locations where the asymptote line is actually crossing this. Okay, and then how many angle. So the first one we need to find this, the asymptote line that intercepts real axis. So in this case, is number of no, the summation of finite poles is -1, -2, plus -3, plus -4, 0, right? And then we use this one, yeah, we use this one. So this the total of zeros is consider 5, I think. So yeah, 5 here. Go back to it. So that's -5, right? Divided by the number of finite poles, which is 5, minus the number of the net 0, which is 1. So then that's 6, 10. Yeah, 10 plus this is 5 divided by 5. So we have -5 over 5. Okay, so not -1. So now we know that this, okay, this is the point here where our asymptote line will cross here. It can be any point line. Okay, now here, right? So we need to find, this is important, we need to find the angle, which is the theta asymptote, right? Theta asymptote. So which is 2k plus 1 multiplied by pi, which is 180 here. Number of finite poles, we can use this one, 5 minus 1. No, sorry, this is not right. 5 minus 1, 4. Look at this one. So it's minus 5 over 4. So it is somewhere here, right? Okay, this is 5 minus 4. We have 4 here. Okay, now we need to increase this k equal to 0, 1, 2, 3, 4. Okay, we can start until 4. It's okay. So now at we put k 0, so the first angle, first theta is 180 over 4. Second theta when k equal to 1, 1 to 3, 3, 180, okay? 3, 180 divided 4 equal to the 3, um, k equal to 2, 6, 4, 5, 5, 180 divided by 4, theta 4. Okay, now we can stop at theta 4 because we need to find 4 angles, right? Only 4 angles because the number of poles, 5, 1 is going to 1 for 0 here, another 4 is going to infinity, so it's 4 angle. So you can stop at 4, you can find this 7 times 180, 180 divided by 4. So what is the its angle? Okay, theta 1 from this calculation here, um, here, right? This. So that's theta 1. I need to don't have bring this calculator. Okay, now 180 divided by 4, 45. Yes, the first one is 45. The second one is 180 times 4. Okay, 45 multiplied by 3, 135. That one, 45 multiplied by 5, 225. 225. And the last one, 45 multiplied by 7, 315. Okay, this is a point. Okay, based from this point, the first angle is 45. You can draw this 45. This is theta 1. Okay, theta 2 is 135. 135 is this direction, right? This is theta 2, 135. Theta 3 is 225. Maybe, yeah, this direction. And then 315, this direction. This theta 4, this theta 3. So this is the asymptote line. Okay. Okay, from here we can actually sketch. Suppose that, okay, this is our, okay, suppose this is 1 point something, 1 point something here, right? So this line is not here, it's a bit, should be here, right? Should be there. Should be there. Okay. Let me draw this. Sorry. Okay, this line. 0, 1, 2, 3, 4. Okay, this is our, this is 45, 135, theta 1, theta 2, 225, theta 3, theta 4, 315. Yeah. Okay. So we have that. Now we know that these two, right, will actually find their own zeros at this direction. So in order for this to be symmetrical, this one is moving to this direction, and then it's actually moving this way. Okay, we stop at there. So because it's going up there along this line. Okay, then the second one here, one, okay, here definitely will actually find the zone 0 here, and then these two will actually find its own 0 to this direction. Okay, so remember this one, you cannot go this to cross this the asymptote. You cannot draw like this because you have to follow this towards this direction. That's what is the purpose of having this um, asymptote lines. So by using that rules, you can simply draw this, okay, um, root locus, right? So in this case, let's see the next one. The next example, g of s is equal to 1 over s plus 2. Okay, now we have two poles, zero zeros. So one here, one here, right? So looking at this, do we have the asymptote? Yes, because they are not enough pair, right? They are not complete pair. Two poles, no zeros. So these two poles will find zeros somewhere in the infinity, but we need to know the directions. The first, we need to find the real point, asymptote point, right? Equal to minus 2 minus 0 minus 0 divided by we have 2 minus 0, right? So that's minus 2 over 2 minus 1. So that is the point minus 1 where this is our real intercept asymptotes, right? And then we need to find the the angle theta asymptotes. Okay, we know that from here we have two angle only, right? So this 2k plus 1 by 180. We need to divide by the number of poles minus zeros here. So this is 2. Okay, theta 1, so just k equal to 0. 0, 180 divided by 2. So we have 90. Okay. We have 90 there. Okay, that's theta 1. Theta 2, that's k equal to 1. 3, 180 divided by 2. Right, so be equal to um, 270. Okay, 270 degrees. So from this point we have theta 1 here, theta 1. There is our theta 2, right? So the direction of this is that this is going to this direction, and this is actually going to this direction. So this is our root locus. So you can draw the root locus here. So actually we don't know this one whether it's going to this direction or this one is going to direction, but it doesn't matter. We need to see that there's a line here. So either one will go to that direction, right? So this is our root locus. So I think we need to see the example after this.